It's day 2. Let's go ahead and get this open and see what we have in it so we can go ahead and move on to the coding. This is going to be for the Projects of Codemas box. We had day 1 here, the USB cord, the Pi, and the breadboard. So let's see what's in day 2. Okay, looks like we have a couple of jumpers, a couple of resistors, and a couple of LEDs. If I remember correctly, looking at the website, these are red, yellow, and green, I think. They're 3 different colors, so even though they're all clear, they all emit a different color. So let's move over to the computer and start coding again. So like I mentioned, we're on the 12 days of Codemas, day 2. So let's look at real quickly at what it has to say. So here's an overview of what is with it. Like I mentioned, there's a red, amber, and green LED, 3 resistors, and some jumpers. Here they are a little laid out better. Description of the project, description of an LED, resistors. So let's get to building the circuit. There are 3 LEDs as we mentioned, but they are all clear lenses. Just one second. You see them there. They're all clear lenses. But on the instructions, we have a specific order they have them in, which I guess isn't super important. The code is still going to work either way. But if you want them to be in the same order, if you want to kind of mimic a stoplight, I'm going to show you how to tell the difference before you get everything wired up. You just need a button cell and know that the top part where all the writing in is positive and your LED. So the positive side you will touch to the longer leg of the LED, and we see that this one is kind of looks red, but I think it's amber. We know that one's green. Green is always bright. And this one will help us determine which one was red and amber. And this one is obviously red. I think in the camera they kind of look the amber and red look the same, but yeah. So right here, let me get back over to the proper screen. Right here it mentions which side is positive and negative. The cathode is the shorter leg, which is negative. The anode, which is positive, is the longer leg. So the blue side is ground, red is positive. So they put the shorter leg on the left side. So again, we'll just follow what they're doing. So we got the 2 LEDs in there currently. Green, amber, and red. Now let's put in the resistors as well. The resistors are going between ground and the cathode. So if you don't know, the way the breadboard works is each line, so see right here it says line 28, that whole line up to the middle is connected together. So anything you put in there will be connected together. The positive rail, that's all connected together, and then ground rail is all connected together. So you only have to power the positive on one and ground it on one, and then the rest is good. So let's do each one. Okay, there. We got them all wired up, at least with the resistors. We're going to have a little bit more to do. So now, if we scroll down a little further on the image, we can see that instead of actually grounding them, we are putting each, or not grounding, instead of powering them off of like the 3v3 rail or something, we're putting each of them to a pin on the Raspberry Pi. And then the ground is grounding that whole rail. So I'm going to go ahead and take, and I'm going to separate these all from one another. They're all currently connected. They just tear apart. And these don't match the same colors as what's on there. But typically, red is going to be used for power and black is for ground. So we're not using a power line this time, kind of, but we are using ground, so we'll go ahead and use black for ground. Okay, I think we got it now. And now we're going to do just above 23, which is right here. And that one is going to go to the closest. Then we're going to do the next one up. That's going to go to amber. And then finally, we're going to go to the next one up. There we go. So we have them all wired together now. Now, let's look at this code. We're just going to copy and paste it into the Thonny. And there we go. It turns all the LEDs on. And then after 5 seconds, it turns them off. So let's take a look at what that code looks like. So we imported the pins just like we did with our first thing the other day, yesterday. Now we're importing time. We're calling out the red LED is on pin 18, amber is on pin 19, and these are pin outs. Green is on pin 20. Taking and turning setting all those values to 1, which turns them on. And then we put in a sleep timer of 5 seconds so that they stay on for that long, and then it turns them off. Pull up this again, and we'll see it run again. So there we go. You see we have red, yellow, or green, yellow, and red all showing. Let's look back at what's next. Now it's gonna flash it. And I mentioned while loops in the yesterday's video, but this is gonna go a little more into them. So let's take and copy the code it has down here, and we'll kind of see if we can figure it out. So it looks like in this code they have started to make notes. So these are the imports from machine, import pin, import time, calling out all of the LEDs like we went before. Now we're setting a counter, and this is, like I mentioned yesterday, the while counter, or while true, caused it to be in an infinite loop because that true would never change to false because there was nothing set to it. So with this one, they're setting a counter at starting at 1, and then the while counter is less than 11, then it will do what's in here. And if you notice down at the bottom, it's a counter plus 1. So this line of code here adds 1 to the counter. And then so once the counter equals 11, then it will stop. So it should be a pretty quick flash. Let's bring up the video of it, and let's run and see what this code looks like. And there we go. It flashes all of them. And look, it's down here in the code, it's counting. So we got to 10, and it ended. And each time it used this to print that counter number. So now, like I mentioned every time, I kind of want to play around with what they gave us, do a little bit with the code, and see what we come up with. So give me 1 second and we will see what I decide, what I come up with. Okay, I made some little edits to the code, and these are simple edits. We'll go over them here in just a second, but let me show you what it does. So I decided to replicate what it looks like when you're driving around, what our red lights work like. I did slow down how long the red light is typically on, though. So I sped up how long the red light is typically on, but everything else is pretty close to real time. Seem about right to you? As soon as it turns green, it changes, right? So yeah, let's move back over. I still have this on the counter, so it's going to go through this cycle 10 times. But just modifying the code like this, and I'll show you what I did, helps you understand how everything is working, how everything goes. So let's look back at the code. So everything is the same for the most part from, at least all of this beginning is the same from the code that they give. So we have import the pins, import time, call out the pins, set the counter, and then while counter is less than 11, so that it'll still run through 10 times. This is where it gets a little different. So we have the print counter, which is the same, but we need to delete this comment. It doesn't matter that the comment's there, it's not going to do anything to the code, but hey, that's not what this code is doing. So we turn on, first, we turn on red for a second, or we turn on red, and then we let it stay on for 2 seconds. Then we turn off red and turn on green. So that's where it switches from red light to green light. Then we wait for 1/4 of a second because that's about all the time we ever have with the green light. And then after that 1/4 second's up, it turns off green and yellow or amber turns on. We wait another 1/2 a second and then amber turns off and it starts back over with red on. So those are easy little changes I made just to kind of play around with it. If you have this kit, create a reel of how you change the code to do different things. Just with these components. Don't add in any of the other stuff next. We'll kind of do the same thing for each one. But let me know what you did. Thanks for tuning in on this. This is day 2. We've got 10 more days to go. We'll see you tomorrow. If you would, give this video a like, subscribe if you haven't,